Hello, welcome all. In the previous video, we learned why BGP exists and what an autonomous system is. Now let's try to answer the big question. How does BGP actually work and how does it decide where the internet traffic should go? Consider these three autonomous systems. At the edge of every autonomous system, there are special routers called as edge routers, also known as border routers. These routers sit at the boundary of a network and connect to routers in other autonomous systems using BGP. These routers are gatekeepers and they decide which routes enter the network, which routes exit the network, and how traffic flows between organizations. Let's talk about what BGP actually exchanges. Unlike protocols such as OSPF, BGP does not exchange full network maps or link states. Instead, BGP exchanges route advertisements, which includes IP prefixes. Let's say the marked router is actually a network with this IP address 10.0.10.0/24. So this AS, which is AS59, can announce saying that I can reach the network 10.0.10.0/24. Some other things that BGP exchanges is also AS path, as we have previously seen. There are few other attributes which are also used for policy decision making. BGP is called a path vector protocol. That means it doesn't just advertise a destination, it also advertises the entire path to reach it. Each time a route passes through an autonomous system, that AS adds its own ASN to the AS path. So let's say we have a route or a network which is 10.0.11.0/24, which is present in AS64. So this route, when it reaches AS59, might look like prefix, which is the 10.0.11.0/24, and AS path, which is 64,000 followed by 13,000 followed by 59. This AS path helps routers avoid routing loops, understand where routes originate, prefer shorter or more trusted paths, and apply some routing policies. So unlike distance vector protocols that only counts for hops, BGP keeps the full path history. So instead of saying here is the shortest path, BGP says here is the destination and here is the path to reach it. When an edge router learns multiple routes to the same prefix, it must decide on which one to choose. So this is where the BGP decision policy comes in place. Let's talk about a simple scenario. Let's say we have a prefix here 10.0.12.0/24 and this prefix needs to be advertised and reached AS59, let's say this router. Now there are two ways to go about it. This prefix can travel from above, which is this path, or from down below, which is this path. Now as you can observe, the number of hops, if we choose the top path, which is this path, is more than the number of hops if we choose the bottom path. However, because the number of ASs from the top path is less than the number of ASs from the bottom path, BGP might often choose the top path, which is choosing the best route can also depend on the local preference, which is which route does the organization prefer, or origin type, where did the route came from, or MED, which is multi-exit discriminator, which has a preferred entry point. There are some more attributes that can also matter in case of the BGP decision process. This means that an operator might intentionally choose a longer route if it is cheaper, more reliable, and better aligned with business contracts. Now let's just visualize how traffic actually flows through ASs when you open your laptop, right? Let's say you open your laptop and search in some website. So this is the source. It will first enter the ISP's edge router, which is the internet provider's edge router. Then it will move through some transit AS, and then it will reach the destination AS. So BGP was designed this way because BGP is policy driven, it is policy aware, it is scalable, it is stable, and it is decentralized. That means BGP must be configured carefully because a single small mistake at an edge router can lead to route leaks or large internet outages. So to summarize, BGP exchanges prefixes, AS paths, and routing attributes. It is a path vector protocol which tracks full AS history. BGP makes routing decisions based on policy and not just the shortest path. Thank you. In the next video, let's discuss the difference between eBGP and iBGP.